Yeah, good morning, guys. After a long time, we have a video on ionic equilibrium. So, in today's class, we'll discuss about ionization constant of weak acid and the weak base. Okay. So, for example, for strong acids, the strong acids completely they will ionized in water. But whenever the thing comes to weak acids, no, so they won't ionize completely and they will be under equilibrium. See, for example, if you have HCl, for example, if you have HCl, so the HCl completely dissociate to produce H plus Cl minus. Okay, and similarly, for example, if you have a weak acid like CH3COOH, so this is a weak acid. This won't undergo ionization completely, like aqueous. Here also aqueous. So here also aqueous. So it won't ionize completely. It will give CH3COO minus aqueous plus H plus. Okay. So in the case of weak acids only, so we'll see how the ionization constant will be for weak acids and the weak base. Okay. So for this, if you want to write the ionization constant, what we will write? So ionization constant directly will write. So Ka is equal to, so concentration of CH3COO minus, okay, and concentration of H plus and concentration of CH3COOH. So this you will write, okay. And here, see, whatever the COOH we have, so entire COOH is not undergoing ionization. Only a fraction of CH3COOH is undergoing ionization. Okay. See, for example, if I took an acid name as HX, okay, I'm taking an example. An acid is HX, and we'll see the ionization constant of that acid. See, for example, I have a weak acid like HX. In aqueous, it gives H plus X minus. Okay, so this is aqueous and this is also aqueous. Okay, let's initially, that is at time 0. So the concentration of this acid is C and concentration of H plus is 0, concentration of X minus also 0. Okay, at equilibrium, so a fraction of this HX ionized into H plus and X minus. So that fraction is C alpha. C is nothing but concentration of this acid. Alpha is nothing but degree of dissociation. What is this degree of dissociation? Alpha is nothing but fraction. We can define as fraction or percentage of the reactant that has reacted. So this is called as alpha. Okay, so the fraction has to react from the original concentration only, right? So because of that reason, so the fraction of dissociation is nothing but C alpha. And how much amount of H plus is formed? C alpha amount is formed. And this is C alpha. Okay. So at equilibrium, the concentration of this HX is decreased by how many times? C alpha times. Okay. So after equilibrium, that means after attaining the equilibrium, so the concentration of HX is C minus C alpha and the concentration of H plus is C alpha and the concentration of X minus is C alpha. Now the dissociation constant for this one is what? So the dissociation constant for this one is concentration of H plus, concentration of X minus by concentration of HX. So this is ionization constant. And coming to H plus, what is the concentration of H plus? So C alpha is the concentration of H plus. And concentration of X minus is C alpha. And concentration of HX after equilibrium is C minus C alpha. I am writing this one as C into C. It is nothing but C square, alpha square, and from here I am taking C as a common, C1 minus alpha. So this is going to give C alpha square by 1 minus alpha. Okay, so remember one thing, for weak acids, the value of alpha is very low compared to 1. So here 1 minus alpha will be approximately equal to 1. So C alpha square. Okay, so what is this? Ka is equal to C alpha square. As Ka is equal to C alpha square, Ka is equal to C alpha square. Then alpha square is equal to what? Alpha square is equal to Ka by C. Then alpha is equal to what? Alpha is equal to square root of Ka by C. So this is what? So this is nothing but degree of dissociation. The degree of dissociation is square root of Ka by C. Okay. From here we can calculate the concentration of H plus. Okay. From previous slide we know that concentration of H plus is C alpha. Substitute the value of alpha here. So let this will be equation number 1. Okay. So what is the value of alpha? So the alpha is equal to C into Ka by C. Okay. So then what you will get? So 1C gets cancelled. You will get square root of Ka into C. Similarly, so Ka into C. So what is Ka into C? So the concentration of H plus is equal to Ka into C. Square root of Ka into C. Okay. Now take logs. So whenever you are taking the logs, so minus log H plus. So minus log H plus is equal to what? Both sides I am taking. So minus log Ka into C power half. Okay, what we know, what is this? Negative logarithm of H. So we know the negative logarithm of H is pH. So the pH is equal to minus log Ka into C power 1 by 2. So pH is equal to minus minus log Ka into C alpha. Okay. So for this one, this is in the form of what? A into B. So write in the form of A plus B. Okay. So minus of log Ka plus log C. So pH is equal to of, I can write this one as minus log Ka minus log C. Okay. So now, so negative logarithm of H plus is what? pH. So what I can write? So negative logarithm of Ka, I am going to write as pKa. So why? Since minus log Ka is equal to pKa. Okay, na? So if you want to calculate the pH of weak acid, so therefore pH of weak acid is equal to half into pKa minus log C. So this is the formula which we can use to calculate the pH of weak acid. Similarly, for a base, take for similarly for a base. So for example, if you have a base like MOH, so this is also weak base. So if this undergoes ionization, we will get M plus and OH minus. Aqueous, aqueous. So initially at T is equal to 0, concentration is C, 0, 0. Okay. After equilibrium, as we discussed in the acids, the concentration of this one is C minus C alpha, and this is C alpha, and this is C alpha. And ionization constant of base is what now? So this is concentration of M plus, concentration of OH minus by concentration of MOH. Okay, substitute the values. C alpha into C alpha, C minus 1 by alpha. So this is C square alpha square C into 1 minus alpha. So C gets cancelled. What you are going to get? C alpha square. Okay. So for weak basis, alpha is very less than 1. So 1 minus alpha is approximately 1 for weak basis. Okay. So that's why you can write C alpha square. So what we got here? Kb is equal to C alpha square. Alpha square is equal to Kb by C. Alpha is equal to square root of Kb by C. Okay. So now concentration of OH minus is what? So the concentration of OH minus is C alpha. So that is C into square root of Kb by C. So here we will get square root of Kb into C. Okay. Similarly, take here minus log OH minus is equal to minus log Kb into C power of. After solving this one, what you will get? So as your acids, pH is equal to half minus pKb minus log C. So this is the formula to calculate basicity of an acid. Okay. And we can write from this. So pH of weak acid is equal to 14 minus half into pKb minus log C. Okay. So this is the thing how to calculate ionization constant of weak acid and weak base. Hope you understand and this video is useful to you. Okay.